Hello everyone. In last lecture we have solved maxima minima problem. Okay, and in today's lecture, that is this is lecture number 3.4, module 3 and fourth lecture. So in this lecture again we will complete the concept of maxima and minima, and we will solve some special type of maxima minima problem. Okay, so let's start. This is our first question of this lecture. Question number 1. A rectangular box open at the top is to have a given capacity V. Okay, find the dimension of the box requiring the least material for its construction. Okay, so let's again read the question, what it is saying. We have a rectangular box. Okay, first data is the box is rectangular box. Okay, so let's say this is our box. Okay, this is rectangular box, and second data is given that open at the top. That means the top portion, the top side is open. Okay, so all other side will be closed. So these sides are closed, all these sides are closed, only the upper portion is open. Is to have a given capacity V. That means its volume is V. Okay, find the dimension of the box requiring the least material for its construction. That means you have to find out the dimension for which to construct this box you need the least material. That means you have to find out the minimum volume. Okay, you have to find out the minimum value. That means it is a minima problem. Clear? So let's find out the solution. Suppose for this box, let's this length is x, the breadth is y, sorry, this is height, breadth is y, and height is z. Clear? So x, y, z are length, breadth, and height. Clear? So let x, y, z be the length, breadth, and height, okay, of the box. And obviously if length is x, breadth is y, and height is z, then what will be volume? V is equals to xyz. Na volume is V is equals to xyz. Okay, and this V is given. That means the volume is given. Okay, we cannot change the value of V. V is a constant value for this particular box. Clear? Now we have to find out the minimum dimension for which we need the least material to construct this box. Clear? Now what is the process? So in maxima minima problem, first of all we need a function. Okay, we need a function. So first of all find out the function. Okay, and you know how to find out the maximum value or minimum value for double variable function xy, f of xy. But here we have three variables na, x, y and z. That means we have to construct a function f which is of two variable. That means we have to put, let's say I am neglecting or I am substituting the value z in place of in the variable of x and y. Okay, so suppose for this rectangular box, what would be the surface area? Total surface area, this is equals to, what is the formula of total surface area? Surface area, there are total, how many sides are there? 1 2 3 4 5 6, 6 sides. Okay, and from these 6 sides, one side is open and the side is the upper portion of xy plane. Okay, that means we are getting one area xy plus two areas of yz, 2yz, and two areas of xz. Okay, two areas of xz, so 2xz. Clear na? So first one is this portion, this is our xz plane. Yes or no? Because the height is z, so this is our xz plane and the opposite of this xz plane, so 2xz. And this side, this is yz and opposite of 2yz, opposite of yz, so total 2yz. And the lower portion, that means this plane is xy. Okay, but for this plane the upper portion is open, so we are getting only xy. Clear? So this is our total surface area, and we can write this surface area in this form, that xy plus 2y into what is z. From here we can write z is equals to v by xy. V is constant because it is given value of the given value of this rectangular box. V is constant, so we can write 2y into v by xy plus 2x into v by xy. Clear? That means we are getting this is equals to xy plus yy cancelled out, yy cancelled, so 2v divided by x plus 2v divided by y, x cancelled. Okay, let's say this is our f of xy. Okay, and let's say this is equation number 1. Okay, so this is our f of xy. Clear? Now the process is same, because we have to construct this box. That means we need the surface area. Okay, and the minimum value or minimum material, we need the minimum material. Okay, so process is same. First we have to find out the first order derivatives, then find out the critical points, then find out the value of h. Okay, so first fx, that means partial derivative of f with respect to x, so this will be y minus 2v by x square. Okay, similarly fy, and obviously fx is equals to 0, and fy is equals to x minus 2v by y square, and this is equals to 0. Okay, let's say this is equation number 2 and equation number 3. Now question is how to find out the value of x and y. Okay, suppose from equation number 2, from 2 we are getting y is equals to 2v by x square. Okay, now the value of y, put the value of y in equation number 3. So putting y is equals to 2v by x square in 3, equation number 3. Okay, so equation number 3 is x minus 2v by y square. So this will be x minus 2v divided by 2v by x square whole square. This is equals to 0. Now after simplifying this equation, you will get the value of x. So or x minus x square x to the power 4. So x to the power 4 divided by 2v by 2v whole square. So this will be 2v. This is equals to 0. If I take common x, so this will be 1 minus x cube by 2v is equals to 0. Okay, this is equals to 1 minus x cube by 2v is equals to 0. Actually, from this equation, we are getting two results. Either x equals to 0 or this factor 1 minus x cube by 2v equals to 0. Okay, we are getting two results, but is it possible that x is equals to 0? No, because x is the length of the box and length cannot be 0. Okay, that's why x is not equals to 0, and you can write here since x not equals to 0. Okay, so from this equation what we are getting, x cube equals to 2v or x is equals to 2v whole to the power 1 by 3. Okay, now you can put the value of x in any one of the two equations. Okay, or you can put in this equation y is equals to 2v by x square. Okay, so y is equals to 2v by what is x, 2v x square, that means this will be 2v to the power 2 by 3. Okay, now after simplifying this, we are getting 2v to the power 1 minus 2 by 3. So this is equals to 2v to the power 1 by 3. Okay, so what is the critical point? So the critical point is 2v to the power 1 by 3 comma 2v to the power 1 by 3. Okay, so critical, we already have gotten the values or the points, critical points. Now we have to find out the value of h. Okay, and to find out the value of h, we need the second order partial derivatives. So first calculate f(x)(x). What is f(x)(x)? Partial derivative of fx with respect to x. And what is fx? This one, y minus 2v by x square. So what will be the derivative of this with respect to x? So this will be minus minus plus. So this will be 2 into 2v divided by x cube. That means 4v by x cube. Okay, so f(x)(x) is equals to 4v by x cube. Okay, similarly fyy equals to 4v by y cube, and fxy means partial derivative of fy with respect to x. So this will be 1. fxy is equals to 1. Okay, now what is h? H is equals to 4v by x cube into 4v by y cube minus fxy square. So this will be 1. Okay, so this is equals to, okay, let's find out the value of h at, actually we are getting only one critical point, so we are going to find out the value of h at this critical point. So h at 2v to the power 1 by 3, 2v to the power 1 by 3. So this is equals to 4v by x cube. So this will be 4v divided by 2v into 4v divided by 2v minus 1. Okay, that means we are getting 4 minus 1 is equals to 3. So obviously this is greater than 0, and greater than 0 means extrema exists. Clear? Now check the minimum or maximum value. Obviously you will get minimum because the question is you have to find out the least material. Okay, so let's check f xx 2v to the power 1 by 3 2v to the power 1 by 3, and this is equals to, what is fxx? Fxx is equals to 4v by x cube, so this will be 4v by 2v to the power 3 by 3, that means 2v. So we are getting 2, and obviously this is greater than 0, that means you will have minimum value. Okay, so hence f has minimum value when x is equals to 2v to the power 1 by 3 and y is equals to 2v to the power 1 by 3. Okay, but here we are getting only the values of x and y, but our given function or our given question is a function of 3 variables. So obviously using the values of x and y, further we have to find out the value of z. Okay, so now z is equals to v by xy na, v by xy, so this is equals to v by 2v whole to the power 1 by 3 into 2v whole to the power 1 by 3. Okay, so if you simplify this, you are getting v by, so this will be 2v whole to the power 2 by 3, that means you are getting this is equals to 1 by 2 to the power 1 by 3 into v to the power 1 minus 2 by 3. Okay, so you are getting v to the power 1 by 3 by 2 to the power 2 by 3. Clear? V to the power 1 by 3 by 2 to the power 2 by 3. If you want to simplify this, so you can write in this form also. This is equals to, let's multiply 2 to both numerator and denominator. So this will be 2v to the power 1 by 3 divided by 2 into 2 to the power 2 by 3. Okay, so this is equals to, okay, let's multiply 2 to the power 1 by 3, 2 to the power 1 by 3, so this will be 2 to the power 1 by 3 into 2 to the power 2 by 3, so this will be 2 now. So we are getting 2v to the power 1 by 3 divided by 2. Clear? So what are the values? X equals to 2v to the power 1 by 3, y equals to 2v to the power 1 by 3, and z equals to 2v to the power 1 by 3 divided by 2. So this is actually the question was find out the dimension. Dekho, find out the dimension, that means you have to find out the values of x, y and z. So this is the answer. Okay, so you can write the final answer. Therefore the length, breadth and height of the given box should be 2v to the power 1 by 3, 2v to the power 1 by 3 and half into 2v to the power 1 by 3 respectively. Clear? Okay, so this is a very important problem, and I think you have understood this one. You can solve almost same type of problem. Let's solve second one. Next question. Find the shortest distance. Find the shortest distance from origin to the surface x y z square equals to 2. Okay, so we have any arbitrary surface x y z square equals to 2, and you have to find out the shortest distance of the surface from the origin. Okay, if you want to understand it graphically, so let's say the arbitrary curve is like this. Okay, so from origin definitely you will get different distances. Okay, different distances, and you have to find out the shortest one, and shortest means you have to actually this one will be from the origin. Okay, so obviously you have to find out the shortest one. Clear? So let's say this is the curve, this is x-axis, this is y-axis. Okay, and let's say this is the any arbitrary curve. Okay, and let's say this is the shortest path, and this point is, let's say this point is P. Okay, and the coordinate of the point P is x y z, and obviously this one is origin 0 comma 0 comma 0. Okay, so let's solve. Solution. So let P x y z be any point on the curve or on the surface, and this is the equation of the surface x y z square equals to 2. And you know how to find out the distance between 2 points or between 2 coordinates. The first point is origin 0 comma 0, and the second point is xyz. So what will be the distance? Distance from origin, this is equals to obviously x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. So this will be x minus 0 square plus y minus 0 square plus z minus 0 square. So this is equals to root over x square plus y square plus z square. Now I am actually, we have to find out the shortest distance now, shortest distance. So let's say this is our f. Okay, so let f x y z, this is equals to x square plus y square plus z square whole to the power half. Clear? But the concept is same. We know how to find out maximum or minimum problems in for 2 variables. So obviously we have to substitute for z. Okay, so what is z square? From this expression we are getting z square equals to 2 by xy. Yes or no? From this expression we are getting z square equals to 2 by xy. So we can write in place of z square that x square plus y square plus 2 by xy. Okay, whole to the power half. So this is our f of xy. Let's say this is equation number, let's say this is equation number 1. Okay, now problem is using this square root, the calculation will be problematic, or the calculation will be critical. Okay, so let's simplify this one. We take g of xy, this is equals to x square plus y square plus 2 by xy. Actually the minimum or maximum value for the function f and for the function g will be same. Okay, the point will be same. Just we have just here g is the square of the function f. Okay, g is the square of the function f. Now our calculation will be on the function g. So we have to find out gx, we have to find out gy, and we have to solve the two equations. Okay, so what is gx? Gx is equals to 2x minus 2 by xy. So this is of the form 1 by x, so minus 1 by x square, so this will be minus 2 by x square y, and this is equals to 0. Okay, and if you simplify this, you will get x cube y, this is equals to 1. After simplifying this, 2 will be common, x into x square y, that will be x cube y, so x cube y equals to 1. Similarly, if you find out gy, okay, gy equals to 0, again you will get, actually gy is equals to 2y minus 2 by xy square, okay, equals to 0. So we are getting x y cube, this is equals to 1. So let's say this is equation number 3, and let's say this is equation number 4. Okay, equation number 3 and equation number 4. Now if we solve equation 3 and 4, solving 3 4, okay, so how to solve these equations? First one is x cube y equals to 1, and second one is x y cube equals to 1. Okay, so if we subtract 3, if we subtract 3 from 4, actually not solving, like let's write subtracting 3 from 4. Anyhow we have to find out the values of x and y. Okay, so this will be x cube y minus xy cube, this is equals to 0. Okay, so if I take common xy, so we are getting x square minus y square equals to 0. So from here x square minus y square equals to 0. Now problem is here xy is not equals to 0. Why? Here xy is not equals to 0. Why? Actually xy z square, okay, if we put, actually what is xy? Xy equals to 2 by z square, or you can say z square equals to 2 by xy. So if xy equals to 0, then z square will be undefined. So obviously xy, product xy, obviously that will be not equals to 0. So x square minus y square equals to 0. So we are getting x equals to plus minus y. Okay, x equals to plus minus y. Now this is the value of x. We need the values of both x and y in some numerical form. Okay, now we can put the value of x in any one of the equations 3 and 4. If we put in equation number, this is x equals to plus minus y, so if we put equation number 3, so we are getting y to the power 4. So let's write putting in 3. So we are getting y to the power 4, this is equals to 1. So I am taking x equals to plus y. Okay, so y to the power 4 equals to 1. So from here y to the power 4 minus 1 equals to 0. That means y square plus 1 into y square minus 1 equals to 0. So we are getting y equals to 1 comma 1 minus 1 comma minus 1. Okay, y square equal, not only minus 1 comma minus 1, actually we are getting 1 comma 1 from this factor. Let's write y to the power 4 minus 1. So we are getting y square plus 1 equals to 0, and y square minus 1 equals to 0. So from here y equals to plus minus I, and from here y equals to plus minus 1. Okay, y equals to plus minus I and y equals to plus minus 1. Similarly, what will be the value when y equals to plus minus I? What will be x? Because x equals to plus minus y na, so this will be again plus minus I, and y, so x, that will be again plus minus 1. Okay, so what are the points we are getting? How many points we are getting? Actually, the points are here we are getting plus 1, 1 comma 1. Okay, next minus 1 comma minus 1. Okay, next I comma I, and minus I comma minus I. Okay, I comma I and minus I comma minus I. Now question is it possible that can we take these 2 points I comma I and minus I comma minus I? No, because here given z square equals to 2 by xy. Yes or no? Z square equals to 2 by xy, and z square, obviously this is greater than 0. Okay, obviously this is greater than 0, so z square will be positive if xy is positive. Yes or no? Z square equals to 2 by xy. Now z square will be positive if the product xy is positive, because 2 is positive integer, so xy must be positive. Yes or no? So in this case xy is 1 positive, in this case xy is 1 positive, in this case xy is minus 1, so we cannot take this one. In this case, what is xy? Again minus 1. Okay, so we cannot take these 2 points. Clear? Why we cannot take the 2 points I comma I and minus I comma minus I? Because in this case the product xy is negative, but product must be positive. Okay, so the points are 1 comma 1 and minus 1 comma minus 1. 1 comma 1 and minus 1 comma minus 1. Okay, so we already have gotten the points. Now we have to find out h, and to find out the value of h we need the second order derivatives. So gxx, what is gx? This is our gx, 2x minus 2 by x square y. So derivative with respect to x, so this will be 2 minus minus plus, so 2 plus 4 by x cube y. 2 plus 4 by x cube y. Okay, similarly gyy, so this is equals to 2 plus 4 by x y cube, and find out gxy. Okay, that means gy and partial derivative with respect to, this is our gy with respect to x, so minus minus plus, so this will be 2 by x square y square, 2 by x square y square. Okay, now find out h xy. So this is equals to 2 plus 4 into x cube y into 2 plus 4 by xy cube minus 4 by x to the power 4 y to the power 4. Okay, now you have to find out the value of g at the 2 points sorry, value of h at the 2 points 1 1 and minus 1 minus 1. Okay, so first we calculate at 1 comma 1. So at 1 comma 1, so h 1 comma 1, this is equals to, so 2 plus 4 into 2 plus 4 minus 4. So obviously this is equals to 6. 66 into 6 36. 36 minus 4 32, obviously greater than 0, and greater than 0 means extrema exists. Okay, now find out gxx at 1 comma 1. So this is equals to, what is gxx? 2 plus 4 by x cube y. So 2 plus x cube y, so at 1 comma 1 that will be 1, so 2 plus 4, so this is equals to 6, again positive, so you will get the minimum value. Okay, you will get the minimum value. Now at minus 1 comma minus 1, okay, you have to find out the shortest distance. Clear? So obviously you will get at the point 1 comma 1 the minimum distance. Then now let's find out for minus 1 comma 1. So h minus 1 comma minus 1, this is equals to, if you calculate, the result will be same, 32 greater than 0, and gxx minus 1 comma 1, that is equals to, again you will get the value 6 greater than 0. Okay, 6 greater than 0. Now so we are getting 2 points, 1 comma 1 and minus 1 comma 1. That means you can say the curve is almost or the surface is almost symmetric. 1 comma 1 means this point, and minus 1 comma 1 means minus 1 comma minus 1 and this point. That means these two distances are same. Okay, and that's why we are getting two shortest distance, okay, in two opposite coordinate planes. Okay, first one in first coordinate, and the second point is on the third coordinate. Clear? So you have to find out the shortest distance, or you have to find out the path. Clear? So here these are the values of x and y, 1 1 and minus 1 comma minus 1. So obviously we need the value of z, and we know that z square equals to 2 by xy. Okay, so when x comma y equals to 1 comma 1, then z equals to root over 2. Okay, again when xy equals to minus 1 comma minus 1, then again z is equals to again root over 2. That means the z value is same. Okay, obviously that will be plus minus 2 because square root na, so that will be plus minus 2. So we are getting the same value of z for the different values of x and y. So what are the points? So the points are 1 comma 1 comma root 2, 1 comma 1 comma minus root 2, because for 1 comma 1 we are getting 2 points plus minus root 2. Similarly minus 1 plus root 2 and minus 1 minus root 2. Okay, these are the points where you will get the minimum distance. Okay, and the shortest, what will be the shortest distance? So, or therefore shortest distance, this is equals to root over what was the formula? X square plus y square plus z square. So 1 square plus 1 square plus root 2 square. If you put minus root 2, answer will be same because we are taking square. So this is equals to 1 plus 1 plus 2. So this is equals to root over 4 equals to 2. Okay, and actually this is plus minus 2, but a distance is always positive, so this is 2. Okay, so in this way you can solve this type of problems. So I think these two problems are clear, and you can practice all the problems from your textbook or from your question paper, question bank, previous year question paper. Okay, thank you so much. Bye.